Good morning, good afternoon, good evening, everybody. My name is Seth Paskin, Director of Marketing here at BMC. With me today is Gayendra Rana, who's Product Manager here at BMC. We are so thrilled that you are joining us for this first in our two-part series on AIOps. And we got a jam-packed agenda. We've got some fun stuff to show you. We're looking forward to your feedback. Before we get started, let's go ahead and just take a look at a very short video about the BMC Helix platform.
Tools everywhere. But how do you bring them together? What if you had one solution that could help your whole team do its best work and follow the framework of the autonomous digital enterprise? You can with BMC Helix's unified service and operations management platform, built with artificial intelligence and machine learning to automate the work of your service and operations teams. You get one central location to set up and manage users, groups, permissions, and access, plus a single expanded data lake for every solution on the platform and ingested third-party data. Dynamic service management to take a business service view of IT, predictively and proactively identify and eliminate issues, and optimize service delivery. Intelligent automation that automates workflows and processes and delivers insights and recommendations to make the best use of your people. AIOps powered observability and actionability that reduces MTTR, optimizes cost and performance, and drives increased innovation, market competitiveness, revenue, and profitability by providing a view of business service health to prioritize risk and align teams to collaborate on response and improvements. And a collaborative containerized application development environment that supports no-code, low-code, and pro-code to speed time to development, all in one platform. What can BMC Helix do for you? What can't it do? Learn more at bmc.com/helix.
So we are going to talk about BMC Helix and how we handle AIOps and observability, but first we want to talk more about why you need a platform approach to solve that problem. We're going to talk about customer needs as well as some market drivers. We're going to focus on required capabilities of the platform to deliver that. Today's focus is on business service modeling, event noise reduction, and root cause isolation. We'll talk about, Rana will tell you how we do it, how we solve it. We're going to give you a demo of how we do it. We'll have room for Q&A at the end. And then just to remind you and tease the next section, part 2, we're going to talk about service prediction and automated remediation. With that, let me hand it over to Rana.
All right. Thank you so much, Sid. So, hey, everyone. My name is Gayendra Rana, and today I'm going to talk about the BMC Helix AIOps. So, as we describe our IT operation portfolio, I want to start with the journey that all of you are on, right? Some of the statistics here is really, really interesting, hard to believe as well as it's just describing 3 or 4 years ahead. Now, just look into these challenges which we have. We have like a lot of talent gap and supporting hybrid work models, right? There is so much of data growing up and there is a lot of people required here. Explosion of so much, again, as I said before, explosion of complex data coming in with so many applications and dependencies, it's very hard to figure out where exactly the problem is happening, right? And with the modern and multi-cloud architectures, along with legacy system, it gives you a lot of challenge in your infrastructure. But with that, what are the things we are going to, what are the trend we are seeing by 2025, right? And this is hard to believe that it is just 3 or 4 years ahead of us, right? So by 2025, nearly 2/3 of the enterprise be prolific software producers with code deployed daily to meet constant demand, right? Over 90% of new apps will be enabling agility and responsiveness. 80% of the code will be externally sourced in response to ongoing needs. And all this with a greater than 20% of all cloud expenditures are wasted, right? Now, let's look into what's happening and why it's happening. What are the typical challenges and needs which we have today, right? So even before I go into the BMC Helix app challenges and required capabilities, let me tell you a story, a very small story, a use case here, which is imagine there is a train ticket booking system, right? The users comes, your business users comes over there, book the ticket, reserve the ticket, and do the transactions and everything, right? This is what every day a user will come and do it. Now, one day, suddenly the user starts complaining, hey, we cannot do any kind of transactions on your system. There is a problem going on. So they create a lot of incidents. Now, at the same time, your monitoring tool is basically raising a lot of events. Hey, there's some problem going on with your train ticket booking system. Go look into it. What really we look into it, what really the capability the users are looking into it is basically, I mean, when I'm talking about the users, the persona which you see here, the NOC operator, the service owner or site reliability engineers, a mechanism where you can correlate all the data together and really figure out where exactly the problem is happening, right? So in that term, so what are the typical challenges which this team faces? Now, there is obviously, as I was talking in my last slide, there is a scaling team to manage growing number of events. When I say growing number of events, it's millions of events. Failing to identify incidents before it happens, right? Can I get a solution which tells me, hey, go look into the problem. There's something which is going to happen. So I fix it, right, ahead of the time. So which obviously helps me in reducing my MTTR, right? Identifying root cause instead of hopping it from one group to another group. Is there a one single place where I can look into what exactly is happening? What are my entities? What are my servers which is impacted and how I can fix it immediately? This can only be done if you can correlate data coming in from one or multiple sources. Now, for these, what we really need is every server or every entity is part of a service or an application. So we need that context. How do we maintain and so how do we create and maintain those service models, right? Can I have a capability which have this AI driven capability? I don't need a team which can just keep on writing policies for these event correlation and reducing the noise, right? So these are like, if you see on the right hand side, the capabilities which I was describing earlier in my use case, the service context, the event correlation, the root cause isolation, and getting the data in. This is what our BMC Helix AIOps solution solves for you, right? With that, I will talk about the required capabilities. So let's look into it. So typically for as I was talking about, like for all these monitoring and observability into the AIOps capabilities, the foundational elements is there an automated way which can just go ahead and observe my topology? When I say observe, it means it can automatically look into all my data and create one service for it, right? And that's what we are calling a dynamic discovery and service modeling. And the part which is very important is data. I need an easy way to get the data in, either through my own sources or from the, the other sources. Like I have typically seen there is like on an average, there's an 11 to 12 monitoring tools in the bigger organizations, right? Is there a way where I can get all these data at one place, just being the manager of manager, and an easy way to get the data in, right? With that, once you have these data in, the typical use cases in the AIOps is like, I'm getting millions of events. I want to reduce the noise, where it says, hey, whatever you're seeing, all those stream of events which is coming into your system, I want to tell, here's the root cause, rest of them are symptoms. So ultimately what I'm doing is I'm reducing the overall noise. And in the process, also telling you where exactly the problem is happening. That is your root cause analysis, where I can tell this is the event which is causing the problem, rest everything is, again, as I said before, are symptoms. The third piece, which is very critical, I call it as a zero MTTR, where we telling ahead of the time that there is a problem going to happen on your system by using the service prediction. It optimizes your resources, looks into all the risks, and identify where exactly the problem is going to happen. So remember, if you are predicting the problem ahead of the time, imagine how much of time and cost it saves. With all these foundation key use cases, the typical thing is what insights, because that's very important, that you want to know what's going on my service. So what insights you get, it's very important. The last piece of this whole cycle is how do we get the, fix this issue. So I told you about what is the problem, why it's a problem. The third piece is how do we fix that problem? And that's where we are going to talk about the intelligent automation. Now, even before we go into the detail of the use cases and the features the AI ops have, let's take a look into our Helix high-level architecture, right? So 3 to 4 years back, typically everything was siloed. In the sense, there were products which is having their own application server, own database server, and they were integrating with other products through an API. Well, that was not a bad approach, but again, very fragile. Now, what I say, we have a platform approach which is completely containerized, cloud native. What does that mean? It helps in scalability and performance. So now what you see here is a high-level architecture of our BMC Helix AIOps solution. On your left, this is your piece where you get the data from your own agents or from the third-party data sources. This will be shown more in the demo, but as we're talking about it, this is one single piece which is getting the data into the platform, and then all those data is being stored in a common data store, right? And then there are some services which is supporting it on top of it. But really the thing is, these things which were a silo product in past now just become a capability on top of this platform using the same data model, right? So now you don't have to integrate with different products, and you don't have to go to the hassle of like, oh, this something has broke, this the other API is not working, there's a version mismatch and all those things, right? You don't have to go and fix those issues because it is a platform, right? Now, not only that, you have one single UI for everything because you have the common data store, you have these capabilities on top of it. Now, all you have to do is use the one single consolidated UI for all these capabilities. With that, you have also an integrated ITSM. Now, you don't have to separately go and configure all those incidents, management, change management things. Everything is done within the platform, within your Helix platform, right? So we are going to talk about what are the typical features over here. Remember, I was talking about the dynamic service model management, automatically observing your topology by just looking into your infrastructure. So this is what we have. What we have is a dynamic service model. Why dynamic? It looks into your infrastructure, it gets all the relationship, it groups them under one service topology, but the dynamicity comes with the recent cloud native initiatives where you have pods and serverless, which those are ephemeral in natures. Those can come and go. The beauty is if I can capture it and automatically publish those new pods or new servers, new serverless coming into your models, you don't have to worry about it. You don't have to go manually publish those things, right? And also, if you have some other sources of data coming into your service, produce a combined topology. That's what dynamic discovery models are about. For example, here, what we have some sources like Dynatrace, SolarWinds, Comps, etc. So many, but also if you have models coming in from your CMDB sources, what we do is we combine them, we give you a reconciled view, and we tell, okay, this is one single service which is basically responsible for your all your infrastructure. One typical application, and it gives you a 360-degree view. What are the different assets over there? Now, we have heard it loud and clear. The hardest part and the most challenging part in any of the, for our IT admins, the SRE, is how do you create and maintain those service models? Now, we came up with a complete new approach, and we call it as a blueprint. So what happens in this case is now you have a template. So imagine a dashboard with all the panels, and it gets lightened up as soon as the data comes in. Now, in this case, very similar, what we have done is we have created a lot of templates out of the box. For example, today we have the Kubernetes blueprint, and when you hit on it, it automatically looks into your data and says, hey, there is already a mapping service to it. Let's create a service model for it. And it's dynamic in nature, so you don't have to keep maintaining it. So what happens is now it's a kind of rinse and repeat. You have the template, create the model, and there's a dynamicity piece added to it. Now you don't have to maintain it. So it's rule based, where if I say, hey, everything on my data center, which is a Linux server, please add it to this service model. So you are easily creating those service model using these blueprints. So there are two aspects to it. Number one, where you are creating these models automatically, means we have the template provided to you. And number two, there is a rule thing added to these blueprints wherever it sees a new server or new asset or new entity coming into the picture, it automatically adds into your service model. And this helps you to create and create and maintain the service model easily with a very simple modeling user interface. So BMC Helix AIOps is, we call it as an open platform. Why we are calling this open platform? The reason is, when we get the data from the third-party sources or from our own BMC agents, we don't treat them differently. Everything coming into the system is a first-class citizen for us. So now what we have is, with our recent acquisition on the Streamweaver, which we did last year, we are able to get the data from the third-party sources, multiple sources, which solves 80 to 90% of the use cases, and it treats all the events, metrics, or topology as a first-class citizen. I'm repeating here because I want to make you understand there is no difference. We do not differentiate between the data coming into our platform from what either your own source or the third-party source, right? So what it's capable of is basically it can ingest a broad set of metrics, events, logs, and the topology. And why it's intelligent? Because it automatically reconciles the data coming in from the multiple sources, like a host coming in from a Dynatrace or from an App Dynamics or from SCORM. We say, okay, this all relate to one host. Let's not have a duplicate here. So we automatically reconciled it and we produce one combined topology. That's the best part of it. And once you have this data coming in, you get the advantage of AI-driven root cause isolation using this data and topology. So remember, I was talking about in my first couple of slides about a use case about the train ticket applications where you're getting the problem. So this is where you're solving the problem. We call the event correlation part as situation, and it helps you in just look into all the events together and tells you, okay, this is my root cause event and rest of them are symptoms without any code. There is no code required. Everything is being done through our AI based algorithm. It looks into your stream of events, groups them together, and proactively tells the user, here is the problem, go and fix it, right? Now, a situation can happen at a time. There is a possibility that there are multiple situations happening on your service. So what we do basically is we group them together, and if there is your service health score is degrading, we also have a functionality of service health score, which looks into your service and looks all around all the situation and events coming into your application or service, and we mark them. We give them a score over there. So if it is degraded over a timeline, we show you a 360-degree view, a holistic view, which we'll also show in the demo, that what are the top causal nodes which is causing the problem in your service. And not only for the folks who likes visual, we have a CI topology which shows where the impact is in your entire services, which entities are getting impacted and why it's getting impacted. And it's not only that, we show the impact flow that due to the problem in a specific server or entity, it is impacting the other servers and entities within your service. So the entire flow is at one place along with those correlated metric, right? So these are events which leads to the situation in isolation, but we do not stop there. We also have log analytics solution. Now, anything which relates to this problem and you have captured that in the log, that will be part of your situation and root cause isolation. So what does that mean? At that time, you can click on that event and see, okay, what was the exactly log says at this piece. So now you get this 360-degree view in form of events, topology, metrics, logs. So as I was talking about in my last slide about the logs, so we do have a log analytics solution which has a capability to add log data from external sources, and you can leverage ML to automatically correlate and cluster similar log messages. You can view the data in the context of the metrics, events, and topology data. When I say visualize, it means that you can have those Kibana dashboards, and as well as you can get the events into your root cause, as I was talking about in my last slide. There is additional storage and the retention which you get with this log analytics piece. So moving on with the next one is I see this feature as a very important, a collaboration or a swarming. So imagine in a knock center, you have thousands of services and service A is managed by group B, C. Now, what you really want to do is if anything, like if your service health score has degraded, you want a way where your group can collaborate, you can swarm, they can look into what issue is going on, and that's where we are providing a collaboration app. Now, this app is not only limited to AIOps. We have one single app for both ITSM as well as AIOps. And as soon as you get a notification, it goes into the groups which you have assigned in your teams. And what it does basically, you can query it, what's going on, why the health score is, what is the health score, what are the events impacting it, and you can also schedule a meeting, you can look into the incidents, you can take some actions right from there or cross launch into the AIOps solution to see exactly what's going on. And if you have initiated an automation, it will show the status, what is the result of that automation. So everything at one place, it's a swarming capability. You don't have to go shop around multiple apps, just one single place. So that's the beauty of the collaboration piece. So last but not the least is the cross-product integration. And I will tie this to the story which I described initially, the train ticket booking system, where your business users were having issues on the payment. Now, the same thing, just imagine that they are creating a lot of incidents that, hey, we cannot do a transaction on your system. And that is coming as an incident over here. Once that comes as an incident, an operator goes and looks into it. Hey, there is some white outage going there, and I see these are my top root causes. These are the entities which is basically impacting the system. What you can do is you can get a teaser over there, right there. What are the entities getting impacted? You can take some actions right from there, or you can cross launch to further diagnose the issue into the AIOps. And then it goes to the same channel. As soon as you look into it, you see what exactly is causing the problem. You run an automation, it fixes the issue and closes the incident. So now what used to happen in hours is taking minutes to fix the issue. So this is our service ops initiative, which actually it gives you a 360-degree view and one persona who can go and look into both the worlds. So with that, I'm going to talk about the key takeaways. Remember about the AIOps situation and root cause isolation, where you can correlate everything and tell exactly where's the root cause and what are the symptoms. We're talking about also in the automation and actionability piece, you can fix the issue. There is a third-party integration. Remember about our open AIOps thing. We treat everything as a first-class citizen, and the collaboration piece, which is very important, the groups coming together and swarming and looking into the issue together. With that, I'll hand it over to Brendan for the demo.
Thanks, Rona. We're going to start with how we get data into the Helix platform and specifically into Helix Operations Management and Helix AIOps, Helix Service Monitoring. So the fundamental requirement for observability is data. We need all kinds of data from a variety of different sources. We, of course, can collect our own data directly in Helix Operations Management. But really, to be a true observability platform, you have to be able to collect data from other sources. So our solution to that is a platform-wide service that we call Helix Intelligent Integrations. And that's what we're looking at now. And so Helix Intelligent Integrations is our integration layer for consuming observability data of 4 major types: metrics, events, topology, and logs. Metrics are the time series data that you typically get from monitoring tools and application performance management tools. Things that tell you, for example, the response time and the page load times of your web applications. Events are for when the tool has actually got thresholds configured and you want to send the alerts generated by that third-party tool, then those events can be consumed through our intelligent integrations piece. Topology is critical for the AIOps portions of the Helix platform because we use that topology data as context for the monitoring information that we're collecting, the events, metrics, and log data. And we use it specifically to correlate and drill down to root cause. So first of all, step 1 of isolating root cause is to understand which pieces of infrastructure are related to which other pieces. That's where the topology data comes in. And typically third-party tools such as application performance management tools like Dynatrace and AppDynamics, they map out the application topology for you. That data is really useful in terms of helping us to analyze root cause. The final type of data that intelligent integrations can collect is log data, which can be fed into our log analytics component of the Helix platform so that we can apply our algorithms to analyzing that data and alerting when we see abnormal behavior as manifested in the log data. So we have a number of different connectors, and these are just examples of the different types of sources that we can consume data from. There are other sources as well, and they're all turned off at the moment. So if I want to actually start collecting my Dynatrace data, I can click on my toggle switch, and now I'm actually streaming data live into our Helix tenant. And in this case, I'm collecting both event data and topology data. As the application topology is updated, we will get fresh data. Where does that data go once we've collected it? Well, it goes into our dynamic service modeling repository, the DSM repository, which is a Helix-wide repository. That means that all of this data, and especially the topology data, which applies to all kinds of different applications, is accessible through all of the different applications on the Helix platform. Ultimately, where we make the best use of it in terms of real-time monitoring and the AIOps use case is in the service monitoring interface. So you can see these are our services, and we can see that we have a service that is actually based on the data that we're collecting from Dynatrace. So that's a model that is showing up in service monitoring, and I'll spend some more time on explaining what's going on here in a moment. Also, we have another window onto the same data. Again, this is the DSM repository through our BMC Helix Discovery solution. So here's that same model viewed in Discovery. And so Discovery stores its data in the DSM repository. And since it's a shared repository, we can see the data that came in from our intelligent integrations component. And finally, we are collecting events from that Dynatrace integration, so we can see those events starting to show up in Helix Operations Management. So that's intelligent integrations and the ingestion part of the equation for AIOps. Next, we're going to have a look at service models and service blueprints. How do you actually create service models that you can use for context and for root cause analysis? So starting back at the Helix portal, we're going to now move on to the Helix Service Monitoring application. So I'm going to scroll down to the bottom here and launch Helix Service Monitoring. This is where we are focusing on the AIOps use cases. So it's understanding what is the current health of my services, and when there is a problem, linking events together that are related to a particular service and to a particular root cause into situations. So helping us to identify root cause faster and to sift through the event noise to get to the underlying issue as quickly as possible and ideally remediate it in an automated way. So the core requirement for all of that is the concept of a service. It could be a technical service, it could be a business service, it could even really be an application. But the idea behind service monitoring, as much as possible, is to orient your services to what the business is expecting you to deliver and what your customers are expecting you to deliver. So in other words, linking the technology to an actual business service that you're delivering. And so the next question is, okay, well, how do these services get into the solution? We've got a number of services here. These are our top 5 services, most important services. How do they get into service monitoring? Well, they can come in from a variety of sources. We've already looked at one of them, which is the intelligent integrations piece that we talked about earlier. We can also bring in service model data from Helix Discovery. Here, for example, we have a service model for our e-ticket application that was built through Discovery and looking at observed communications. But often what we're getting from Discovery might be an application model or even sometimes just collections of infrastructure that may not obviously coalesce into a service. You may want to actually be able to create a service by hand, or at least partially by hand, within the service monitoring application. And so we allow you to do that. We give you a number of different ways to do it, but the most efficient way to go about it is to use a service blueprint. You can see we have a couple of service blueprints available out of the box, and you are free to design your own. The idea behind a service blueprint is we are taking not specific infrastructure components, but using a template-based approach, which allows us to dynamically select what is part of our business service. So I'm looking at the Kubernetes blueprint, and the key with the Kubernetes blueprint is that everything is linked to the namespace. If you're not familiar with Kubernetes, the namespace typically maps to an application, and then underneath the namespace you have deployments, and linked closely to the deployments is the software pod. So these are the microservices that make up your application. And of course, everything's running on servers eventually and on a cluster of servers in your Kubernetes cluster. So here we're using this as a template to build a business service based on the namespace. We're going to pick a namespace, and then all of these other classes of objects under the namespace will automatically be linked to our business service. So with this service blueprint, we have exactly one question to answer when we build our business service, which is, what namespace do you want to link into the service? Everything else will flow from that because the namespace will be linked to the deployments and pods and so on. So that's essentially what the service blueprint is for, is it just provides a template that we then link into the data that is sitting in our DSM repository. So let's close the blueprints and let's use the blueprint to actually build a business service. And so we're going to go back to our business services view, or at least this is a new view, which is the heat map view. Everything's green, which is always nice to see. We're going to create a new service based on that service blueprint we just looked at. All right, so the first thing I get is a business service object. I'm going to give it a name. Let's call it something suitably business-like, risk management. And you can see I have 2 ways of creating a service. One is through adding static content. Static content is what its name implies. We are actually linking specific objects from our DSM repository. They might have come in through Discovery or have been created through intelligent integrations. But we're linking in specific objects, which, as you can imagine, might be a laborious process. And it's also not dynamic in the sense that if our service changes, we have to come back here and edit the model. Hence, the value of service blueprints. So we're going to go back and add dynamic content. Up pop our service blueprints, our 2 available service blueprints. We're going to use the Kubernetes blueprint. And this is where we have to answer the one and only question, which is, which of your namespaces do you want to use as the anchoring object for the business service? I'm just going to select the default. I can preview what that business service looks like. So I can see that this has all been aggregated. So the service is more complex than this, but I can see that I've got a namespace. Underneath that, 12 deployments, 12 pods, 1 per deployment, and then the host and the cluster that all of this links to. I could see the disaggregated service if I wanted to, so you can see there's much more going on there than we were looking at through the aggregated view. But the net of it is that's all there is. That's all I had to do. That's all there is to defining a business service using the service blueprint concept. So I'm going to save my business service, save and close again. I get a success message saying that the service has been successfully saved. And now I have a brand new risk management service showing up in my heat map, and I can drill down on that service. And there we are again looking at the aggregated components of the business service. This is the simplified view that is really designed to be the easiest view for an operations person to quickly hone in on what is the key thing that's going on with my service. Right now there's nothing going on. We have a health score of 100. Next we're going to look at what happens when things go wrong with a service. How do we get to the root cause quickly? So that's our next part of our demonstration. All right, we're back at the service dashboard, and we can see that the e-ticketing application is actually having a problem at the moment. It's no longer green. It's we've got a number of events outstanding. It looks like we've generated a couple of incidents. Those may have been generated automatically, or users may have actually created those tickets, but they've been linked to the CIs, the configuration items that underpin our e-ticket application. And we can see we've got 2 CIs in particular that are having issues. So I could drill down into the details of what's wrong with e-ticketing, but before I do that, I'm just going to jump back to our overview so we can see the overview dashboard, which gives us some additional information. We can see again e-ticketing application at the top of my list because it's actually got a problem. We can also see that we've got a couple of situations open for e-ticketing. A situation is a cluster of events that we believe are related, and they are clustered together in terms of cause and effect relationships. So we cluster events that we believe are related, and we help you identify the root cause. We actually identify the root cause for you, or the most likely root cause. And we're using machine learning to do this. We use this little icon to identify these as machine learning-based situations, as distinct from traditional event correlation, which we can do. That's policy-driven, much more manual. This is really the wave of the future, is to use machine learning to do this kind of analysis for you. And so let's drill down on the e-ticketing application to get more information. So this is what we call the timeline view. It gives us a lot of information at a glance. We can see the health score. Right now we're at 90, which is not great. It's not bad. The service is still up. We can see the timeline over the last 3 hours. So we can see when the problem started and how long we've been in this unhealthy state. And we can click on any part of the timeline if we want to go back in time and see what was the state of affairs at that moment in time. And clicking on the timeline, you can see I've actually selected the topology view of the service model. So I can see in this case, everything's green at that point in time. If I go back to the current time in the timeline, I can see that I've got a couple of nodes in the user service and travel plan service are actually showing 50% probability of being the root cause of this issue that I'm having with my ticketing application. So I'm going to go back to my root cause view. You can see that we've identified 2 issues as I should say hosts or nodes that are the cause of our problem with e-ticketing. We've got a CPU utilization issue on one, and it looks like a CPU utilization issue on the other, less severe. We can drill down into the details of that. Let's actually, before we do that, why don't we choose the situations view of the world. We'll drill down on the situation because that allows us to see all of the clusters of related events that have come in for our e-ticketing application. So I've drilled down on one of my 2 situations, the one that has the critical event open for it. This is related to my user service. So this is a deployment within my Kubernetes-based e-ticketing application. So I've identified, again, through the algorithm that the most likely root cause is CPU utilization, but I've also got issues with memory utilization crossing a threshold, as well as volume of total bytes of network data flowing through the network interface on that particular node. So this basically is designed to help you reduce the alert noise so that you can see where there are cause and effect relationships between things. We will isolate those relationships for you, link them to a particular piece of infrastructure, and allow you to get to root cause much more quickly. So with that, I will wrap up my demonstration and pass the baton back to Seth and Rana. Thank you.
All right. Hey, Brendan, thank you so much for that demo. I think it really highlights the power of the solution and shows you how we actually do all of the things that Rana described. I know we've had a lot of chat and Q&A during the course of the webinar, but we want to open it up now to any additional questions or concerns that you have. Please use the Q&A or the chat window here, and we'll close those out. And when we're done, we'll go ahead and end the session. Thanks everybody for your time and attention. As a reminder, we're going to be doing part 2 of this webinar on June 23rd, and there we'll be talking more about some of the other things that Rana mentioned when we talked about the capabilities, specifically service prediction, which is about how to get predictive and proactive about managing the health of the services, as well as going into more depth about the intelligent automation that Rana described in the actionability piece of this. All right, well, I hope everybody has a wonderful day or evening, and with that, we'll close the session.
Thank you so much.